This is the shape of the future. This is Starship, the most modern, efficient business aircraft in the sky. Starship has been the most exciting new concept in general aviation ever since it made its first dramatic appearance at Love Field in Dallas at the 1983 NBAA. It's even more true today, as the reality of Starship unfolds and people come to recognize the logical beauty of its tandem wing design and the unparalleled efficiency of its all-composite construction. Starship is an airplane as vital and forward-looking as the companies it will serve. It will provide the executives who fly in it with a new standard in corporate transportation that will endure for years to come. At the home of Beech Aircraft Corporation in Wichita, Kansas, the first full-scale Starships are beginning to take shape. Over 500,000 square feet of manufacturing and engineering space in 2 separate plants are dedicated entirely to Starship. Inside, highly skilled Beechcrafters are hard at work to achieve its certification and production by the end of 1986. Starship began life here, on these computer terminals. Starting with a clean screen, Beech engineers have fashioned an airplane whose form follows function. Every line of Starship, from its forward wing to its rear-mounted propellers, was designed to create the ultimate in business transportation. It is, in a word, logical. The propellers are positioned to assure minimum impact on cabin noise levels. For the same reason, the engines are mounted on the wing rather than the fuselage, and they are kept as close to the centerline as possible to minimize the effect of asymmetric thrust in single-engine operation. The main wing, designed with the aid of computers and fine-tuned by more than 470 hours of flight testing, consists of 5 different airfoils on each side to optimize performance. Recognizing that a conventional tail would create a huge sounding board, transmitting engine and propeller noise to the cabin, Beech engineers decided to control the yaw axis with tip sails, which also convert the force of wingtip vortices into additional thrust. The variable geometry forward wing acts as an elevator, permits a greater center of gravity range, and allows the use of high-lift Fowler flaps on the main wing. It provides the best of both worlds, low drag when swept back in cruise configuration, and high lift when needed for slow-speed maneuvering in takeoff and landing configuration. Starship will be the largest, fastest airplane ever certified at 12,500 pounds. Its main wing is over 54 feet long. Its length is more than 45 feet, and it is 12.5 feet from the gear to the top of its tip sails. Its cabin is a foot wider, 9 inches taller, and more than 3 feet longer than the Super King Airs. And Starship will be capable of speeds in excess of 400 miles per hour. This is made possible by composite construction, which is lighter in weight, yet stronger than traditional aluminum construction. Composites also can be formed smoother and more accurately than aluminum. For the first time, designers will be able to fully exploit the performance possibilities of laminar flow, which can only be achieved with geometrically correct surface contour. Yes, Starship's design has a logical beauty that is breathtaking to behold. But more important, it is a logical beauty that works. In more than 470 hours of flight testing with the 85% scale prototype, Beech has proven the soundness of the basic design. From its first flight, the 85% airplane's results have been spectacular. On its maiden voyage, Starship rotated smoothly and climbed quickly to 10,000 feet. It flew close formation with its chase plane, and when it landed an hour and a half later, reverse thrust alone stopped it in less than 800 feet. Since then, it has flown as high as 42,250 feet, and at speeds in excess of 400 miles an hour. It has demonstrated excellent stability in asymmetrical configurations throughout its entire speed range. While the 85% prototype has been proving the integrity of its design, Beech has been aggressively proceeding to put full-scale Starships into the air, and its manufacturing facilities are now ready to begin commercial production. Honeycomb core material is prepared in the cutting area to supply the layup process. Major parts are laid up, then sent to the autoclaves for curing. One of the largest autoclaves in the world has been installed to support Starship production. 25 feet in diameter and 60 feet long, it can cure an entire wing and a fuselage simultaneously. This large investment in production facilities is indicative of Beech's commitment to Starship. This commitment is already yielding significant results. The first full-scale Starship, serial number NC-1, is nearing completion. Its fuselage was constructed using a filament winding process in which the entire unit is created on a mandrel as a single piece. Almost 900 miles of graphite composite filament are spun into a completed fuselage in less than 24 hours. Now, hundreds of items are being fitted into the fuselage shell: wiring, windows, doors, the environmental system, controls, and cables. Outside, the forward wing is in place, the windshield is installed, and the nose and aft fuselage sections are attached. Construction of NC-1's wing has been proceeding simultaneously. Starship wings are created in the main layup area, one of the largest clean rooms in the world. After curing and installation of spars and ribs, the lower wing box is fitted with wiring, fuel and hydraulic lines, control cables, and attachments. Then, all items unable to withstand the final curing temperature are removed. The lower wing box and upper wing skin panel are thoroughly cleaned, and the upper wing skin is carefully set in place. And a locator tool is attached to hold the wing securely during bonding in the specially built 20 by 60 foot oven. Segmented to direct heat to specific areas, the oven's overhead elements are shaped like Starship's wing for the greatest possible efficiency. After final bonding, the wing moves to the wing assembly jig for the attachment of leading edges, landing gear, control surfaces, and other accessories. At last, NC-1's wing and fuselage are ready for mating. Attaching the wing to the fuselage is a major step in the creation of Starship, the culmination of years of design, analysis, tool making, layup, and assembly. And as the mating takes place, work is also underway on the wing and fuselage of the second Starship, NC-2. After the wing and fuselage are joined, Starships move onto the final assembly line for installation of systems and controls. Then a quick trip to the paint shop and to the completion center next to the present King Airline for engines, avionics, and interiors. And finally, flight. The logical beauty of Starship in flight speaks for itself. A stunningly efficient airplane that is designed to have an operating cost significantly below that of current turboprop aircraft and far below that of pure jets. An airplane of the future with traditional Beechcraft systems reliability. An airplane that is an established classic before it ever rolls off the assembly line. And like other classics in any field, is virtually assured of holding its value. But the most logically beautiful aspect of Starship is its heritage. It is a Beechcraft, designed and manufactured by the premier producer of business aircraft with a proven track record of market leadership. Starship is here. It is now. It awaits your decision to join the future.